Hi, everyone. Welcome to SMAP, those who are new, and welcome back to everyone. I'm going to be leading a presentation on the phases of the moon. But without further ado, we're going to take a look at the moon. My screen is frozen. Okay, so when I teach, I generally have people talk. So until I get a response, I'm not necessarily going to the next slide. So you can chat, you can unmute wherever you want, but I want at least someone to respond. When you think about the moon, what comes to mind? What do you think about? Doesn't need to be scientific, it could be cultural, it could be art, whatever. But what do you think when you hear the moon? Oh, we get messages in the chat. The Apollo program, yeah, that's cool. It's a satellite, yep. Natural satellite, good. There's eclipses. We have phases. Yep, that's going to be what we're going to look at specifically. So there's a lot of stuff about the moon. Oh, a bright circle in the sky at night. Yes. It's not always a perfect circle, though. That comes to the phases. So the moon's important. You guys just list a lot of things. We spent a lot of money to get there in the Apollo program, for instance. But the moon's important to us, and it has a lot of impact, not just in science, but pop culture. One of the most famous images from a movie, yep, tides, that's another one, good, is over here. At least when I think of the moon, I always think of this magical image. Anyone know what movie this is? A TA can answer too. E.T. Yep. Cool. I didn't know if I'd be dating myself. Yep, that's from E.T. This image is so iconic, Spielberg uses it for his production company, Illuminate Entertainment. Gorgeous. The moon's magical. We write a lot of songs about it. Paul Simon literally wrote a song, Paul song about the moon. So it's pretty synonymous with humans, but do animals care about the moon? Or can you think about any animals that care about the moon? Any thoughts? Nocturnal animals, yeah, that's important to them. Cool. Yes. So now one thing is, I think an animal that's usually really closely associated with the moon are wolves. So do wolves actually howl at the moon or not? What do you guys think? You can put true or false in the chat. False. Okay, one false. Anyone else want to weigh in? True, question mark, false, true, question mark. Loving the trues having question marks, but the falses being with conviction. Anyone else? True. Ooh, that true has more conviction. Cool. Okay, so the answer is wolves are actually just as active when the moon is a full moon, not a full moon, or what have you. And they don't actually change their behavior based on the moon. In fact, wolves are not up during night, they're up during dawn and dusk. They sleep in the middle of the day and they sleep in the middle of the night. And the reason we associate moons with the wolves is back when colonials came over to America and they were looking at the local animals, they saw more wolves when there was a full moon because it's easier to see the wolves when there's a full moon. The moon has had an influence on humanity. So I saw a bunch of someone mentioning tides. That is a physical impact. There's phases of the moon, but are there any other things that the moon has impacted humanity with? So how else has the moon cropped into our culture? Spiritual culture, yeah, Earth's orbit. Anything else? Incentive for spaceflight, yep. Would we have gone to space without the moon? Would we have gotten to Mars already if there wasn't a moon to get to in the first place? No? Okay. Nathan has a lot of no's. So, REM songs, yep. The moon affects us in many ways. You have tides where it's literally pulling where the water is. In human cultures, a lot of calendars have been based on the moon, and we use the moon and the phase of the moon for farmers across the globe to decide when to harvest. You may have heard of harvest moons before, and you might notice a month is about the length of one moon cycle. It's not quite for us, but they're all calendars explicitly based off of the moon, such as the Chinese New Year. The Chinese calendar is based on the moon. We have a bunch of love songs about the moon. Yep, the month length, and there's a bunch of cultural folklore. So like it or not, the moon has played a lot of significance. And one of the things that has been magical about the moon to people is its phasing. And that's how it comes into playing a month. If the moon always looked the same, we probably wouldn't use it for months. Full moon fever, yep, it's all good. Cool. So we're going to talk about how and why phases happen. So I believe Dr. Dave is going to open up a poll about why are there phases of the moon, and we can see what you guys think at the moment. So Dr. Dave, can you open up the poll? Okay, so students, if you could just answer the off shadow, good, okay. There's the off shadow. It could be sun shadow or light from the sun or lack of it, clouds in the sky, or something else. Okay. Oop, some last minute. Cool. So right now, most of you are thinking B is due to the sun's light or its shadow. A few of you think it's the off. No one thinks it's clouds. That's good. And some of you think it might be something else. Well, let's see and discuss this, and then at the end, hopefully you can describe the answer to this question to your friends and family. Let's start closer to home. Off. So when you look at phases of the moon, let's stop sharing, okay? Okay, when you look at phases of the moon are when the moon is lit up, and we can see there's some light part and there's some dark parts. So let's think about off. Is the off always completely lit up? Yes or no? It's everywhere in the off light at the same time. No, good. So why is there not always light on everywhere in the off? Why is that? Due to the rotation, because the other half is pointing away from the sun. Yes, the off rotates, exactly. We have an off that's spinning, and only the part facing the sun will be light, and the other half will be dark. So that's where night and day come from. So this is what it could kind of look like from space if you're looking at the off, where you will see it rotating through the light of the sun and out of it. So the same thing can happens with the moon. Here's the sun, here's off, here's the moon, and if we're looking here, only the half of the off facing the sun is in daytime. The moon also has daytime and nighttime. So yep, Nathan, I see you're talking about relativity. You're right, the Earth's gravity is not quite that strong to bend light, but massive objects can bend light. That's a good thought. So, in my diagram, does anyone know why my reasoning is for making the sun so small? Distance. Yes. So instead of drawing a very large sun, I've made a very small one to apply the distance. And if you were to print this out and take the sun and place it where the moon is, you hopefully would see that I made the sun and the moon roughly the same size. That's because in our sky, the moon and the sun take up the same same size, more or less. That's why we can have total eclipses, if any of you check that out later. Now, the moon is actually much farther away from the Earth than this image, but you can't get everything right in a computer screen and actually see stuff. So, one thing I do want to point out, you might notice here how the orbit of the moon is not flat with respect to the line from the Earth to the sun. There's a bit of a tilt. This is exaggerated, I believe it's about a 5-degree tilt. So this means the moon is orbiting in a plane that's not necessarily always the same as the plane of the sun. And that's something important to consider. If the planes will always align, eclipses will be far, far more common, but they're not. So we're going to look at this. As the moon moves, the part of the moon that's lit up actually always stays the same because of the moon's rotation. We actually can only ever see the same part of the moon. The part in day is kind of locked, always facing the sun. However, the part we can see depends on where the moon is with respect to the Earth. And the part that's lit up is not always the same as the part that is in the dark. And the part that's lit up is not always the same as the half we can see from the Earth at a given time. So we're going to explore that in more detail today. So for instance, we can make a 2D drawing of this where I'm collapsing the moon to be on the same plane for a 2D image. This is not always true, as I said. If the moon was always on the same plane, you could always get eclipses, which you can't. However, for ease of drawing, we're going to draw it like this. So for instance, if you were to say here, we know that only the half facing the Earth is visible, half not facing the Earth is invisible. The half facing the sun is in light, the half not facing the sun is in dark. So, in this case, we can't see any of the sunlight from where the moon is with respect to Earth. The reflected light from the moon due to the sun. All we see is a dark patch, which here, where we will see any of the moon. And you can do this type of diagram wherever you want to put the moon. Like if I put the moon up here, anyone predicting what we see in the sky? What could we see in the sky if we put the moon up there? Thoughts? A half moon. Yep. The false quarter, yeah, you're getting more technical, Matthew. Good. Half. So we were to do the same thing. We will get the half of the moon is always lit up, but if we're looking from the Earth, we can only see half of it, and now the half that aligns with what we can see covers half of the dark and half of the light. So what we see is a half moon, or the false quarter moon. As the moon wraps around, we're going to see more and more of it. However, there's a bunch of phases of the moon, and this is what you're going to be looking at in the first breakout room, that your TAs are going to guide you through an activity using your OREOs. So, you're going... Yep.
Jonathan, I actually had a question.
Yes.
I noticed that you put, said first quarter phase of the moon, but half of it was lit up. Does anyone know why it's called the first quarter instead of first half?
Good question. Because there was the other side. Yeah, anyone else? Okay, it's 1/4 of the first cycle. Yeah. So if we look at, I can't see my own video right now. Thomas, can you tell me if I'm showing the paper?
Yep,
yeah.
I can see it.
Yeah, so what we do is when we're talking about the orbit of the moon, we'll say going around once is one orbit. So when the moon goes around from here to here, where we see the half moon there, we call that the false quarter because we've only gone through 1/4 of the orbit. When we get back, this will be half of orbit, but you can see a full moon here. And when you come here, it's back to only seeing half of a moon, but we've gone through 3/4 of the orbit. So that's going to be called a third quarter, or the last quarter. But good. Okay. So the TAs are going to guide you through an activity exploring the moon around the Earth and guessing what the phase will look like and drawing some images, as well as playing with your OREOs. So, Thomas, you think everyone's ready to go into breakout rooms?
I think so. I know I am.
Okay.
Is it going to be any different from the first quarter? Are we going to be seeing half the moon? And what half will we be seeing if we're standing here looking up at the last quarter? Anyone have any ideas? Yeah, and exactly. We're going to be seeing the other half of the moon. So the half that wasn't illuminated in the first quarter. Yeah. Very good. So the new moon, full moon, and both quarters are pretty easy to think about, right? So what if we moved our half Oreo to, I don't know, the waxing crescent, right? What are we going to see? Oh, also, quick question. Does anyone know what gibbous means? Or why we call it a gibbous on the moon? We have waxing and waning gibbous. What does gibbous mean? That giving that answer will actually spoil what we'll be seeing for the moon. So I'll tell you guys after we figure out what we'll see for a waxing and waning gibbous. Let's say here we have a waning crescent now, right? We're here on Earth, looking up to this waxing crescent. Does anyone have any ideas of what we'll see for that? It's going to be it's going to be a little more difficult and different to describe from first quarter and third quarter.
You can also just grab a pencil and shade it in, and maybe you can show it to us on your camera.
Yeah. Or you could describe with an Oreo what you may see.
Yeah.
Anything goes. Or you can just type in chat. Doesn't matter. So let me ask you this. So this is going to be in between our new moon, where we see nothing, right? And our first quarter, where we see the first half of the moon. Let's see. We got, Anish said it will be like a curve covering part of the moon. Very good. Yeah, so we're only going to be able to see a little bit of this half that's been illuminated. And you can think about it like we're going from this new moon, where we can see nothing, and to this first quarter where we can see half the moon. So we're only going to be able to see less than half, but more than nothing. And it's called a crescent because it will be forming, well, crescent. And that waxing there means that it's in the process of getting bigger. So every night, that crescent moon is going to look a little bigger until it gets to that first quarter. Very good, Anish. Now, what if we do something similar again?
Thomas, I'd like to have either you or Utica. We should have thought of this in advance, but so we see the Oreo and we see, the half that's illuminated. But if we're going to see a crescent, it might be a good idea to just draw next to, draw another image next to the Oreo, what that crescent would look like.
I think Utica had that idea as well. That's a good idea. Utica, do you want to show them what that would look like?
So for the crescent, so it does look like a curved part of the moon, and it's less than 50%. So it's between the new moon, which is completely dark, and the first quarter that is half of the moon. So it looks like that.
This is my interpretation of a crescent moon. You can see mine's really thin, and a little asymmetrical, but it gets the point across. Do you want to go through the same process for like a waxing gibbous with them and kind of show what that would look like? So maybe I can give you guys a hint by what gibbous actually means. So in Latin, gibbous actually meant hump. So there's something curved upwards, a convex curve, which means the curve is going outwards. So does that give you guys any indication of what a gibbous, a waxing gibbous might look like? We kind of look at it as the process of, we went from the crescent, just small, first quarter, which was half. Now we have to get to the full moon. So what's going to have to happen for us to get to the full moon?
That is my interpretation of a waxing gibbous. So as you can see, that is more than half of the moon. But it's not full moon yet. So there's a little sliver that is still dark, and the rest of the moon is lit up.
There we go. I think that looks pretty good. You guys can use the same kind of process we did for the waxing crescent and gibbous to fill in the waning crescent and gibbous. Now, another little hint for that, waning means decreasing.
So welcome back, you guys all hopefully had a good time with your Oreos. Have a question before we get back. Did everyone just have the normal chocolate Oreos, or did anyone have special Oreos like mint or whatnot?
I'll say I got the mega stuff, and I found it was way easier to do this activity with the mega stuff because it wasn't as hard to pull them apart and cut it.
Cool. Yeah, I see someone's moon was not green, and that a good amount of you had double stuff. Cool. Yes. I just had the normal ones. I stole some from Dr. Dave on Thursday. So, okay. Hopefully you guys considered how the moon looks in the different diagrams and maybe try to draw or make with the frosting what the phases will look like from Earth. Hudson, do you want to share your Oreo cam?
So this is what our group got. I hope everybody else's matches that pretty well. With the Oreos, we've done what the phases look like from the view of the sun and the earth, like we have in the diagram. And then we went ahead and drew what we thought they would look like from Earth as well.
Okay, cool. I can see the Earth diagrams. I know some people did it where they make the phases with the Oreos instead of drawing them, which is also cool. Nathan, are you cool if people look at your video? Yeah? Okay. What he did, he made what the phases look like with the Oreos instead of drawing them, which is also pretty neat. Takes a bit more artistic skills, I think, to use the knife. But that is all. Oh, those are the remains. Cool. Well, nice. So let's get back to the presentation. We'll wrap this up. You guys can keep your artwork or you can eat your artwork, whichever you prefer. Many Oreos will harm. I guess the Oreo protection group will hit kill for that. So here's a video of the phases. So what you see is where the moon is, and you can see what we see from the Earth. So there's a new moon, there's a waxing crescent, the false quarter, waxing gibbous, full moon, when we can see all of it, waning gibbous, last quarter, waning, and finally new. So I know that went a bit fast, but I also have a diagram here where you can see the new moon. So here is what it looks like from above, and then the images right here on the top are what the moon looked like from the Earth. So we have a couple words here, waxing and waning. So waxing is when the part of the moon you can see is increasing. And it's kind of like you're adding layers of wax on something, or at least that's how I think about it. And waning means that the amount of the moon you can see is decreasing. So you will see that it takes the moon about 27 days to orbit the Earth, but the lunar cycle from new moon to new moon is 29.5. So they're not quite aligned, and they're also not quite a month. They're close to a month, but not quite. But this is how lots of Asian peoples will keep time, will be using the moon. Okay, so we have a couple other points I want to make. So you can have phases that happen anywhere. These images from Apollo missions, and look at the Earth. If you're on the moon, you can't always see the Earth completely. The same thing happens from the moon's perspective of Earth, because likewise, half of the Earth will be lit up, but the half that's lit up is not always the same as the half you can see from the moon. Oh, message in the chat. Okay, you ate all the other halves. Good for you. So your tummy should be happy. So wherever you are in space, if you have planets and moons and a star illuminating them, you will see some type of phasing due to this optical phenomenon. So to bring it back to the question at the start, the phases of the moon are not caused by the Earth's shadow or the Earth blocking the sunlight. If the Earth was blocking the sunlight, that would be the case of an eclipse, a lunar eclipse. But the phases we see are due to the arrangements of the moon with respect to the sun, sunning in light, and what light we can actually see from Earth. So, and here's a nice diagram where you can see, just like we showed the moon going through phases, here's the Earth going through phases. So half the moon is always, so to recap, half of the moon is always illuminated by the sun. Half of the moon is always visible from the Earth. However, the halves are not the same. And we get lunar phases here. So, hope you guys had fun. If you want to learn more about the moon, or specifically the Apollo program, I have some recommendations you can check out. On the right is a book called Apollo 8, which talks about the first mission of people to the moon, not the first moon landing. Anyone remember what the first moon landing was? Which mission? 11, yeah. Apollo 11 was the first moon landing. However, before we went to the moon, oh, that's a nice, yeah. Before we went, anyone know the astronauts' names? That's a good one. Anyone remember? Yep. Good. Awesome. Armstrong, Aldrin, and Collins. And Armstrong, does anyone know what school he went to? He went to Purdue. He got an engineering degree from Purdue. So if you go to campus, you can see the Neil Armstrong Hall of Engineering. He's not the only astronaut from Purdue. We have others. 26 or 27. I would challenge anyone to name all 27 by heart. But another famous astronaut who went to Purdue was Gus Grissom, and there is a building on Purdue also named after that astronaut, Grissom Hall. Gus Grissom was, in fact, supposed to be who NASA wanted to be the first person on the moon because he was in the Mercury missions and the Gemini missions, but he unfortunately died in the first Apollo mission, Apollo 1. But you guys find this stuff interesting. You can ask more questions when we're done if you want to stay and ask. But let me get back to my recommendations. The book Apollo 8 is the first time we went around with people that orbited the moon, which is a very important moon mission, not as widely known as 11, but just as important. And that book is really quite enjoyable. If you like audiobooks, I like the audiobook. Yep. There's an Armstrong documentary too. Armstrong also has a movie called False Man. On the left, you see a Blu-ray, but you can also find this at HBO. From the Earth to the Moon is a 12-episode miniseries where each episode more or less focuses on a different mission from the Apollo program, starting with episode 2. So episode 2 is Apollo 1, and you keep getting episodes for each manned mission. So there's a whole episode on Apollo 8, there's a whole episode on Apollo 11, 12, 13, 14, 15, 16, and 17. So I highly recommend. Each episode is like a mini movie of that. If any of you have HBO, you can watch it on the streaming service, or you can check it out from your local library. So, if you enjoyed us today, before we break out to any last minute questions, you can follow SMAP and see some of our exciting videos and lessons like this you may have missed on the Saturday Morning Astrophysics at Purdue YouTube channel. And you can also follow me at my YouTube channel where I make short films and educational videos. Like here, it's mainly short films, but one of the videos you can see relativity for my niece. My 7-year-old niece texted her mom if I could make something explaining time dilation for her. So I got that message as like, well, I guess I have to. I can't say no to that cute of a face. So you can check that out. Or you can check out Thomas in That Good Night playing one of my students, and Eclipses also playing a student for perhaps the rudest professor ever.
I have a question for the students, if you don't mind.
Okay. Yeah, you ask it, then I can answer the questions in the chat.
Do you guys know if other objects can have phases besides the moon and the Earth? I will say I only know of one that's that has consistently been recorded, and that's Venus. Galileo recorded the phases of Venus when he was studying, or when he first started looking through his telescope. So it was one of the things that actually proved the heliocentric model of the solar system. So
Heliocentric means the sun's at the center. For a while, we thought it was a geocentric where the Earth was in the center. So good point, Hudson.
So another question for you guys. If you get, I think one of you said anything that orbits has phases. Why don't we see phases for like Saturn or Jupiter?
Hudson, I'm not sure if anyone's going to speak up, but why can't we see phases of Jupiter or Saturn?
Yeah, it's just they're so far away from us. The scale of the solar system is pretty crazy. They're so far away that we're pretty much always seeing the same side that's illuminated from the sun, even if we're really far apart or really close together. The distance is still basically the same, so we're always seeing the same side of those as far as the sun is concerned.
Yeah, because the Earth is kind of right here, and then Saturn and Jupiter are all the way here. So kind of the side facing the sun will more or less look like the side facing us. And at that point, they'll kind of point lights much more. Good. Okay, so there were a couple point questions in the class. So someone asked me what made me want to study or interest in the moon. So my research is not actually the moon itself. I research dark energy and cosmology, specifically the expansion of the universe. However, I've been interested in the moon more or less because of seeing programmed movies and TV shows about the Apollo program. So in addition to what I shared, there's Apollo 13, the movie with Tom Hanks, and just a lot of other stuff. My interest in space may more or less be from that, liking to know how things work and just watching Star Trek as a child. I see Thomas talked about merit scholarships. And in addition to scholarships at Purdue, I believe there's a website that I used to use called scholarship.com or .net, where you can kind of just list what grade in school you are, what your interests are, where you live, and it would just search a bunch of scholarships you can apply to that you might not even know. So there's a lot of people willing to give you money. But one thing I want to say, only apply to scholarships that you can apply to for free. Don't apply to scholarships you pay to apply. Those tend to be scams. Just one more thing to say before we go. Next month, our SMAP session will be hosted by one of the TAs in this very room, if he's still here. Anu, do you want to give a preview of what the next session will be?
Yeah, for sure. So next month we have a really exciting topic. It's a really interesting topic to discuss about. We're going to be talking about aliens. So alien civilization, exoplanets. We're going to be talking about things like the Great Filter, which I don't know if many people know about. So it's going to be an interesting discussion. And yeah, it's going to be a really, I feel, engaging topic to talk about. Obviously, there's a lot of research going on in those fields right now, and we don't really have a good answer for many of the questions that we're going to be asking. So it's going to be a very open-ended kind of discussion. So yeah, I'm very excited for it. And yeah, I hope to see a lot of you guys then.
I think that might be everything, Dave.
Yes, Jonathan, thank you very much. Your camera is freezing. We're getting snapshots, but you don't seem live anymore. We do hear your audio. Thank you for a great session. Thank you to the TAs and of course to the students attending. We'll see you next time, next month in Saturday Morning Astro at Purdue. Take care, everybody.
Thank you.
I ate all my Oreos. I feel sick now. Well, hopefully your mom doesn't blame us if you throw up.
That's not a pleasant thought, Jonathan. Not something I want to think about.